Hi folks, so the question we have in front of us here today, guys, is the 2019 Ordinary Level Geologic Geometry question, sometimes known as the Rhodes question. It is from the Ordinary Level paper, as I said, 2019. So just going to read a bit of information here. So it's Section C, Applied Graphics, okay, Geologic Geometry, Section C1. The image on the right shows an aerial view of an open mine, so you can see the open mine here. A portion of a similar mine area is represented on the accompanying map located on the back of Section A. So basically this map here that is supplied with the paper usually comes on the back of Section A. The map shows ground contours at 5 meter vertical intervals. Okay, so you can see there I've underlined 5 meter vertical intervals, that's important. Part A, on the map supplied, draw a vertical section profile along on the line AB. So you can see here the line AB, it's like a vertical cutting section has gone through the mountain, represent what the profile of that mountain, okay, or the topography of the map is up here in the space provided. Part B, point C, D and E are outcrop points on the surface of a stratum of ore. Draw the plan and elevation of the triangle CDE, so quite easy to do in plan, we just have to locate an elevation. And then part of the stratum. Okay, so first of all, what we have to be aware of, as I said, is 5 meter vertical interval. So if you look here, we can see 50 to 45, the gap between them is 5. Now if we come over to our scale here, our scale is 1 is to 1000. What that means is 1 on our sheet, OS, is to 1000 in reality. So it's 1 millimeter on my sheet is to 1000 millimeters in reality. 1 millimeter on the sheet is to 1000 millimeters in reality. Now we know that 1000 millimeters equates to 1 meter. So what do I have to multiply this by to make up 5 meters? Okay, which is the distance between our between our contours. So 1000 millimeters is equal to 1 meter. I need to make it up to 5 meters, so I multiply it by 5. Okay, that means I also multiply this by 5. So 5 millimeters on my sheet is equal to 5000 millimeters in reality. So that's kind of the magic number I'm going to be using there. Okay, so we're going to start off with this profile here, and essentially what it says is on the map slide, draw a vertical section profile on the line AB. Now essentially it's like we took a sheet of paper and we sliced through the mountain, okay, going vertically up and down, okay, and it's cutting through all of these contours. You can see here it's cutting through at A here at contour 50, and it's cutting through B here at the contour 55, and we want to basically see what's the lowest and the highest along the way. So 50, my lowest is 45 so far. Yeah, 45 is my lowest, just looking along the contours that go through it, and my highest seems to be 80. So what I would usually do here is I would start here on the right hand side or the left hand side. My lowest is 45, so I'm going to start here at 40 right there along that line there. 40 height, okay. I could obviously start at 0, but there's no point obviously using 0 and then going up 5, 10, 15 and so on. Okay, it makes sense to start at 40, which is just below our 45. And I'm going to measure up in distances of 5 millimeters from here. So 45, 50, 55, 60, 65, 70, 75, 80. Okay, so that's enough space there. And what I'm going to do is put in those contour heights as if I was looking at them in elevation. You have to remember we're looking straight at the mountain now, or the topography of the land. So these contours are all spaced 5 millimeters apart on my sheet, which is 5 meters in reality. Okay, so as I said, that was the first one, which is at 40. Okay, we can skip this one. We have 50, 60, 70 and 80, and you can just see here 75, 65, 55, 45. Okay, so you can see the heights and the contours. Start at 40, 45, 50, 55, 60. Okay, essentially what it is it's a person standing here looking straight at that cutting line or that vertical cutting section A, B there. Okay, and what we're going to do now is we're going to plot where the contour lines cut through the vertical section profile. So very first one here, this one is at 50. I'm going to project where it is at A up to my 50 contour height. Likewise with the next one, this one's at 45. You keep going in this sequence, 45. Next one's at 50. Then we have 55. Then we have 60. 65. 70. 75. You can see here it's cutting through the 80 in two positions, right here and here. Then it's going back down to 75, 70, 65, 60, and finally to be at 55. Okay, and you can kind of see basically the kind of shape of the mountain there. So what I'm actually going to do is, where it's just kind of at those positions, just make a little mark. I often find it helps. And what I'm going to do is I'm going to sketch in that profile. So I'll speed up the video there now. So there we have it, guys. That there is the part A of the question, where we did the vertical section profile on the line AB. So this is kind of what you would see if you were to slice through the mountain along the line AB there. Okay. Now the second part of the question, part B, it says points C, D and E are outcrop points on the surface of a stratum of ore. Draw the plan and elevation. Okay. So of the triangle CDE. So quite easy. They've given us the points in plan. So I'm just going to connect up all the points. We get marks just for doing this. C, D, and E. So essentially, these are points C, D, and E of a stratum of ore. The ore being, it could be gold or whatever it is, coal or whatever you're searching for or mining for. Okay, and these are outcrop points where they're essentially almost coming to the surface. And what we have to do is we have to identify them. So we can see here C is at a height. If we follow the contour, we can see that C is on 45. So right there. So that's where C is, right there. So we're going to identify that, and it's on the 45 contour. Because you have to treat this as the plan view of it, CDE. Now I have to find the elevation. So there's C. Likewise with D, you can see D is on the 75, followed around. So that is going to go up as far as the 75. And then finally, sorry, that's D there, trying to keep everything neat and tidy, and we can see E, if we follow it around, is on 55. So there is E. Likewise, in my elevation, I need to connect up the triangle CD and E. So there we have it. That is the elevation of our triangle CDE, and that there is the part B done, drawing the elevation and plan view of a stratum of ore, okay, as it comes to the surface outcrop points. And now what we do is we have to, part C, determine the strike and dip of the stratum. Okay, so the strike, guys, is found by doing a level line in your elevation or plan technically, but it usually is done from the elevation. So if you look at our triangle or outcrop point CDE here in our elevation, it's generally done from the mid-level height. So we can see C is the lowest, E is in the middle, and D is the highest. So from E, what I'm going to do is I'm going to do a line parallel to the XY line. So kind of using our principle of planes here. And what I'm going to do is where that cuts, you can see that line that I've done across there, where that cuts my edge, C to D, I'm going to project that down to my plan. And also identify it where it is in plan. So you can see here it was on the line CD, so same thing here in plan. I'm going to connect that to E. Actually put it in red now. That line there is called my strike. Right in strike there. That's called your strike. Okay, that's my strike line. That's the first part done. Determine the strike and dip of the stratum. We found the strike. So the strike is done by getting a level line in your elevation from the midpoint height, okay, projecting that across until where it cuts another edge of the outcrop points, okay, the edge C to D in this case, and where I found that, project it down to my plan and then join it to E, and that there is my strike. And what's important to note is that strike is actually a true length, TL there, okay. The reason it's a true length is because in my elevation, it's coming across from E, okay, that line is extending horizontally across, which is actually parallel with our horizontal plane. Because it's parallel with our horizontal plane in elevation, therefore that makes it a true length in my plan view. So anytime then we have a true length, if we look along the true length, like that, okay, in the direction of the true length, okay, so essentially it's like taking a biro and looking along the length of the biro to see it as a point view. So if I look along that true length, I will see that line there, the strike line, as a point view, which E will be on. But what's important to note is because that's a true length there, and when I look along that line there, because the whole surface is on the line, I'm going to see the whole surface CDE as an edge view. And what's important to note then is that that surface CDE as an edge view, that will help me determine the dip. And the dip is basically the inclination the outcrops, okay, or this plane surface CDE will make with the horizontal plane. So what I'm going to do, I'm going to extend out parallel to my X1 or to my strike line. I'm going to set up an X1, Y1 perpendicular to that. I'm going to call it X1, Y1. And I'm now going to project out C and D as well. Yeah, C won't have to come up too far. And D is the highest point. Nice and easy. So what you do at this point then is you simply take the perpendicular distances of each one of them. And what's important to note here, and this is actually quite easy, okay, you could use your compass. So for D, I could take the distance from here to here, take that distance right there, okay. So projecting from the plan, take our heights from the elevation, I could take that distance and mark it out like that, down there. Or what's easier to notice is because I measured up in increments of 5, okay, so I could just easily measure up in increments of 5 as well. So you can see D then is 5, 10, 15, 20, 25, 30, 35 up. So if I check this, it should be 35, and you can see that it is. So I'm happy with that. So that there, right there at that point, is called D1. Okay. Likewise, I'm going to do the same method. So for E, I can see it's up 5, 10, 15. So I'm going to mark out E there. Make sure it's fairly accurate. Not exactly accurate, actually. So right there, that there is E1. And then to find C, I can see it's up a distance of 5 millimeters. To be 100% accurate here now. And if I am 100% accurate, all of these basically here, C1, D1, E1 should meet in a line, okay, which is actually our edge view. So what I usually do is I connect the furthest ones away and check then if the middle one is going through it, and we can see it actually is here, so I know my accuracy is quite good here then. And if I've done that right, extend that down, and what I've actually found here is our X1, Y1 is representing our ground now, and what we've actually found is an edge view of our surface CDE. Okay, so this is an edge view where I'm essentially seeing, if you think of this triangle here as our CDE, I'm essentially seeing it as a line like that essentially. And what's important to note is that the angle in there is your dip, that angle in there. So if we wanted, okay, they've asked us to find a dip, we have found a dip, it's right in dip there, but if you wanted then you could obviously get your protractor, and it's telling me that my dip is 0, 10, and it's not 20, it's about 10, I'm sorry, apologies, 20, 21, 22, 23, it's about 24 degrees there. Okay, and that's my dip angle that it makes with the horizontal plane. Okay, that there, guys, is the 2019 ordinary level question. Okay, profiles and the strike and dip, they're very, very important information. Okay, hope all that helpful, guys. That's that complete.